Heuristic enumeration of odd integers as sums of 3 primes, excluding 1. Aaron Cattell. Abstract. We investigate a heuristic method for expressing odd integers n greater than or equal to 7 as sums of 3 prime numbers, where 1 is not treated as a prime. For each such n, we enumerate all unordered triples of primes that sum to n, then examine the largest prime in the last 3 triples, ordered lexicographically. We define a function f, n, to capture the mode, most frequent value, among these last prime entries. This approach reveals structural tendencies in additive prime decompositions. Definitions. Let P equals, P set membership symbol NP is a prime and P greater than or equal to 2. For each odd integer n greater than or equal to 7, define triples, n, equals, P1 P2 P3, set membership symbol 3 P1 P plus P2 plus P3 equals n, 1 P less than or equal to 2 P less than or equal to 3 P. Permutations are not considered distinct, only non-decreasing sequences are used. Let the last 3 elements, in lexicographic order, of triples, n, be T1, T2, T3. Set membership symbol triples, n. Define the multis-A of their maximum elements. M, n, equals max, T, I. I equals 1 2 3. Then the heuristic function is f, n, equals mode, m, n. If a mode does not exist, i.e., all values in m, n, are distinct, then f, n may be undefined or chosen arbitrarily among them. 1. Example. Let n equals 15. Then triples, 15, includes 2, 211, 357, 555. Sorted lexicographically, the last 3 are exactly these. The maximum primes in each. Max, 2 to 11, equals 11, max, 357, equals 7, max, 555, equals 5. Hence, M, 15, equals, 1175, F, 15, equals mode, M, 15, equals 11. Observations. This heuristic offers insights into the structure of prime decompositions. The function f, n, tends to fluctuate but exhibits local regularities. Excluding 1 as a prime significantly reduces the number of available triples, especially for small n. Conclusion. While this approach does not constitute a formal proof of any conjecture, for example, Goldbach's, it supports exploratory analysis of the additive structure of primes. The function f, n, based on the tail of the lexicographic triple list, captures meaningful biases in prime usage. 2.